Please take your seats. We're good? Yeah, it'll be up in a second. All right, I'd like to introduce our next speaker, which is Bill Senf, and the title of his talk is Are You Aware of Claims? And I'm going to let him do his own introduction for him, so I won't ramble on. Welcome, Bill.
Thank you very much. Hey, wow, I got fans. I have to warn you ahead of time that I'm a walker-arounder. I'm not normally a stand in one place and talker, so if I wander away from the microphone and it's a problem for the video, somebody will like wave at me or throw something or like that. No, I'll never, because I talk with my hands. It's bad no matter what. Normally I just work without a mic because I talk so loud, but I know you guys have some recording stuff going on, and I'm not going to mess around. Anyway, hi, my name's Bill Senf, and I'm here to talk about identity management. And what we're going to do is we're going to take a really broad definition of a term that Microsoft has been throwing around called claims-based security, claims-based identity. And I say broad because Microsoft has this very rich ecosystem for this identity management, and I want to narrow it for the purpose of this talk and make it real general. We're going to say a user has a token, and the token has claims, and that's it. That is claims-based identity. So what this does is it creates an environment for decentralized access control, which at odds with discretionary access control, which is what we're normally dealing with. So that allows me to talk about both OpenID/OAuth along with the ADFS/WIF that Microsoft is coming up with. People say they're not the same, but you'll find there's a lot more similarities than you think, and that's largely what I'm here to talk about. But first, let's talk about me, because why not, right? I am not part of the security infrastructure, the security community, though I'm awed at times at how open-armed everyone's been towards accepting me into talking about things like identity management. I'm a software architect. I'm the person who attempts not to build software with screaming huge SQL injection holes and only encrypting my passwords with one MD5 hash and not using any salt. Not that anybody else would do something like that. I do work in Columbus, Ohio. I'm an independent consultant. I do a lot of work with state government and also a fair amount of private work. And I specialize in Microsoft technology, but that's not the only thing I've done by any stretch of the imagination. I'm an author. I've been writing for about 12 years. I've written all kinds of weird little books, mostly on Microsoft topics, though some other topics. I've written for ROX. I've written for Addison Wesley. I've written for Wiley. And it's neat, though I will admit I'm one of those who prefers to have written rather than writing, if you know what I mean. I'm very much a family guy. I've a wife and two beautiful children who we homeschool and have a ton of fun because we can run around during the day and not have to worry about schedules and crap like that. And we do neat stuff. Normally they drag along with me, but they couldn't come up here today, even though they would have liked to, because there's all kinds of fun stuff to do in Cleveland. I actually am a ninja. I train in ninjutsu in the Columbus Ninjutsu Club in Columbus. I'm 5th Q. Please don't test me. I'm a little out of shape in case you can't tell. I'm also a home brewer. I brew my own beer. I did not bring any. I'm sorry. Sorry. I have a wonderful, wonderful, very hoppy American ale. If anybody likes bitter beer, that'll be done in about 2 weeks. So call me, and if you're flying through Columbus, let me know when you can have a pint or 6. I'm also a lock sport enthusiast. Yes. I run the Columbus branch of Locksport International, and I'm actually the administrative director of Locksport International as well, and handle creation of new chapters and getting people involved in Locksport and stuff like that. This crowd, I don't need to tell any of you about it. You all know. Normally I speak to development crowds, and they're like, Locksport, what's that? But I assume I don't need to do my normal spiel here. I've been writing for a while, and it kind of pegs me as a little bit more of an analyzer, thinker, problem solver than a stand-up and convincer. I'm not a real good salesman. In fact, back in my previous life as a musician, when I worked for a sales organization in music, Coil Music out of Columbus, and I was a sales rep. And they were trying to make the company more formal, and they brought in somebody to give all the sales reps tests to see what kind of salesman they are. And what they determined is that I don't care whether people like me or not, so I'm actually a very poor salesman. And at the time, I was shocked by that. In the 20 years since then, give or take, I've learned that they're exactly right, and I do very much suck as a salesman. So take that for what it's worth as I talk. So let's talk about Bob and Alice. Bob and Alice are doing a little bit of moonlighting for me from the cryptography world. Bob is living in a discretionary role-based world, and Alice has a set of claims. Okay? What's more, Bob is a doctor. Bob? Hello? There he is. Okay, good. See? Bob's a doctor. What's more, he's a heart surgeon. Okay? And he likes to work for a living, like we all do, but everywhere he goes, he has these troubles. Every hospital wants him to prove that he knows what he knows, and they test him consistently over and over again. And every time he comes in and there's a different procedure that needs to be done, he needs to prove that he knows how to do the procedure. And every patient wants to quiz him and ask him, hey, tell me what you've done, tell me who else you've worked on over and over and over and over and over again. He needs to revalidate his checklist of claims every single time he interacts with any system. And it's a little frustrating. Alice, on the other hand, Alice? Okay, I apparently put a space in there. I do not know why. Alice, as it turns out, is a doctor too. Who knew? All those years we've been watching them in cryptography stuff, we didn't know this. I didn't know anyway. And she also is a heart surgeon. Who knew? However, she has a diploma from Trent University. Did somebody get that, or was that? No, nobody got it. Okay. Trent's the trusted party in cryptography. Never mind. When she applies to work at the hospital, they just ask her for her diploma. Right? And she has to prove it's real, of course. And what's more, the diploma says right on it that she's a heart surgeon. So when people come to get work done, get their heart worked on, or get advice or whatever, they don't have to continuously revalidate her. They just look at her diploma and go, oh, okay, well, I trust Trent University. They know what they're doing. She has a diploma from there. Everything must be cool. So let's take a look at when Alice wants to get a job. She goes and she says, hey, hospital, I want a job. And the hospital says, well, that's awesome, but we need a diploma. And we only accept diplomas for certain places, and it has to have certain things on it, or we won't accept it. She goes, oh, well, I'll just send an email to Trent University and get my diploma. And Trent says, oh, yeah, cool. We know who you are. We'll validate your identity first, of course, right? But I'll get you a diploma. We'll sign it, so it's proof that it's real. We'll send it back to you. And Alice says, thank you very much. I'll send that to the hospital. The hospital goes, cool, that's Alice's diploma. Fantastic. We'll validate that to make sure that it's exactly what we expect. And then, ta-da, that's all she wrote. She's got her job because she's proven that she is who she says she is, and she knows what she says she knows. There's a problem with discretionary role-based security. And the problem starts, 15 years ago when Bob got his Novell NetWare account. And so he had a digital identity at work, all right? And then 5 years ago, he set up with a Yahoo Mail account. So now he's got an identity at Yahoo. Well, over the last 3 years, public and private identity repositories have popped up everywhere. So now everyone has a copy of Bob's identity. And it might have his name spelled wrong in one place, and it might have an old email address in another place, and it becomes a management nightmare for Bob. He has to remember so many passwords, he needs a password keeper. And then he lost the password to the password keeper. One of the sites he has an account with got hacked, and all the passwords got downloaded. They were storing in plain text. And then somebody got on the site and baggy pantsed him. He can't win. He can't control anything. And that scope kind of describes the whole problem with discretionary access control. You create silos of users that are incorrect. The user doesn't have any control. He often forgets they're there. You can't share information between them often because everyone has their own scheme for storage. It creates a complex management system for the holders of the identity. They have to stay in touch with the user to make sure that everything is current in the identity. And it presents a really interesting reversal of control where the user should be in control of their own identity, but instead, each application is. And that provides a tremendous amount of risk because the application is now responsible for doing things like preventing escalation of privilege. There's more information in the application than there absolutely must be in this scenario, and that is a bad thing. What's more, as we learned with the password manager and everything else, it provides a bad user experience. You guys all know the big list of passwords that people keep on the post-it note on the side of their monitor. That's what you live to defend against often, at least professionally, and that is partially caused by this discretionary identity management scheme. An example that I put in here, mostly to talk to the dev crowd, so forgive me if this is kind of beneath everyone in the room, but the AT exploit in Windows XP, you pull up a command prompt, I'm probably all familiar with this, and then tell it you want to set command.exe for sometime in the future, and then you wait for it to run command.exe. This is back in XP, back in the day. Wait for command.exe to be run by the AT scheduler. Of course, it runs in the context of the system account. You can then kill your console application, kill your Explorer, use the command.exe that was run by the scheduler to run Explorer again, and ta-da! You are now the system account, right? That shouldn't ever happen, because the machine has more information about users than it absolutely must have. The user should come to the machine with the identity, not the machine store the identities within it. Now, of course, Microsoft fixed that bug, but all they did was say, oh, no, you can't run command.exe interactive anymore. Well, they didn't actually fix the problem at all, did they? Because the concept of the system account is still alive and well within even Windows 7. There's still more information within even that application than there absolutely must be. So Alice. Let's talk about Alice. Well, let's start down here. Alice has a single identity with a chain of claims. It's encrypted and verified by a trusted third party, and she uses it everywhere she goes. She uses it at home. She uses it at work. She uses it to comment on the blog she reads. She uses it to check her mail. Somewhere there is an identity repository that she and all of these end places trusts. And it is in charge of authenticating her identity. Now, each of these places may have their own claims that relate to her identity, but the actual identity information isn't in any of these places any longer. So there's a Bob and Alice story. Let's talk about claim-based identity management and why it's important, who is doing it, with what, how you can get started, and then a couple of what-if scenarios. What if it doesn't work the way we say? What if? Starting with why. 4 good reasons why claim-based security, claim-based identity management is important. Flexibility, interoperability, single sign-on, and federation. Let's start with flexibility. So here's your app. Your application has to authenticate its users. Now, when you started, you had a username and a password box, but then the boss came and said, hey, we're putting in this Radius system. You need to accept authentication from that. So you had to go and get the Radius API and do a bunch of coding and set up that piece, right? And now we're going to do the certificates for certain privileged users. And, oh, hey, can't we make it so you can just accept their Windows authentication? And, hey, we've got this Kerberos system. We'd really like to include that in this application from a user perspective. And, oh, for the administrators, we're going to need to do a rectal scan or something and get their biometric information. Each one of these identity management systems has their own API for you to develop a login system with. And that is exceedingly frustrating. This is what it should look like. You should have a common API for all identity schemes, and you shouldn't have to do logins at all. The user should come to you with their identity in their hand, and that is what claim-based identity will do, distributed identity management will do. It will allow the user to just come to your application or your system with their identity in their hand and their list of claims. Interoperability is another important piece of all this. And I'm going to talk about the who's in a few minutes, but there's two standards at play here that are both OASIS standards. SAML is one, and OpenID is the other. They're both based loosely on WS star, and before you throw things at me, I know that WS star is a mess, and it's way too thick, and it's really hard to deal with, and it's really hard to manage, but they're doing a very good job of creating substandards based on substandards, I gotta find out the word for that, based on the principles laid down by WS star. Those principles are very sound. So for those of you who aren't web services people in the room, this is a standard for XML packet passing, right? Whereas you can store information in an XML envelope, or in the case of OpenID, in a URI instead, that contains certain information and can be cryptographically signed. So this is the SAML packet. Well, this is a very, very high-level view of the SAML packet. We'll talk about that when we get to who. We're still on why. The third why is single sign-on. And this is something people have been playing with for a long time. They have, the Ohio Department of Health builds a portal. You sign into the portal, and the portal passes your credentials to all the applications, and each application has to be built to accept whatever the portal hands to it in terms of an identity. What's wrong with that? Well, each app has to be able to handle the identity handed to it. I mean, if you buy a third-party application, you're toast. You can't integrate it into the portal unless it itself has a very rich API, and then you have to do a ton of coding, and it's very brittle. If you do it with a standard instead, then you have single sign-on no matter what application you're using. Finally, federation, which especially in the case of SAML, is an extremely, extremely important reason why all of this claims-based stuff is important. And this wonderful diagram, and this is where I'm stepping into you guys' space a little bit. Most of you are probably infrastructure people, so forgive my application developers kind of perspective on this, but you have an external user who wants to access certain web apps inside of your perimeter network. Well, we can do that by storing certain claims about the user and some kind of lightweight directory service off to the side of our application, and then use, in the Microsoft world, a product called ADFS, Active Directory Federation Services, to link up the internal domain, which manages all the identification for your users, and a perimeter domain, which maintains all the identification for anybody else that might want to use your application. Now, the NTFS trust along the bottom there will only do certain things for you, and you certainly don't want your internal domain to trust the perimeter domain. It goes the other way. So ADFS will broker identity management for you within the enterprise. And the real benefit of this is that when the external user is sitting on a domain of their own. Now, of course, if the external user isn't, say it's a citizen, then their identity information will probably be in the perimeter domain, right? However, if they happen to be, say, for instance, the Franklin County Board of Health or whatever like that, and the external user wants to use your web application, then we can set up a further ADFS trust for the domain that they're sitting on, so their Windows identity is used to access that application. The LDS is still holding the entitlements, let's say, so that we can take that identity that we already know about and attach it to certain things that the user can do within the application. So it's not like we're handing out authorization to another application. It's just the authentication. We trust that external domain to authenticate this user for us. And the basic claim set, hey, I am Bill Semth, and I'm coming from the Franklin County Board of Health, and I am a manager there, and I'm in this building. That list of claims comes from the external domain to our application via a common API called Windows Identity Foundation. We'll talk about that in a few minutes. And this can be repeated then as many times as you want. So if you have an enterprise where you have a large body of users sitting on their own domains, say you're a private sector company that has a lot of vendors, you can trust with the ADFS trust each of their domains so that the authentication is handled internally to their system rather than you having to create and manage a completely separate set of user repositories for the users that are using your applications. let's talk about who. There are two players to this game. The big guys are using SAML, security assertion markup language. This is Microsoft and IBM is who this is. There's some other players, but Microsoft and IBM pretty much own it, and Microsoft is the only person that actually has a product that's doing anything with it. It's ADFS. And SAML is, well, I'll tell you what SAML is in just a minute. Outside of SAML, there's the field. Pretty much everybody else. And most of them are using OpenID, which is another standard managed by Oasis. OpenID and SAML are different. I won't lie to you. But they do the same thing from the perspective of the user. OpenID is much more trending towards single sign-on than it is to a chain of claims. In fact, the packet you get from OpenID, if you choose to trust them as a trusted third party for identity management, is pretty much just a URI for the user that is unique to that user, and the fact that they are authenticated and maybe their name, and that's it. So it's really up to you to do the actual claim management within your application. OpenID is driven by HTTP rather than XML. So it is really well suited for internet sites. And in fact, that's what you see when you go to a blog and the blog at the bottom says, hey, click here to sign in with your Twitter account to comment on my blog. That's what's happening, is more or less an OpenID transaction. Now that could be actually via OAuth, which is a slightly different take on OpenID, but it's basically the same concept. SAML, on the other hand, is much more driven towards federation than single sign-on, though of course it can do single sign-on, and it is an extremely rich, dense XML format, very much like everything else Microsoft does. It's very configuration over convention. It's very everything to everybody. The standard is hundreds of, if not thousands of pages long, and it's almost impossible to decipher manually. However, what it does provide is a very, very rich privacy model, because everything has a very thick layer of encryption at many different levels. Whereas OpenID depends entirely upon SSL, SAML has many layers of encryption and trust verification built right into the standard. Now, real quick on OAuth versus OpenID, I kind of use them interchangeably for the purposes of this talk, but they are different. OpenID is used for single sign-on. It is sign on to myopenid.com with your URL, mine is semf.myopenid.com, or Facebook or whatever, and then every site that chooses to trust an OpenID standard will allow you to be authenticated, okay? OAuth is more about sharing. For instance, probably many of you use Twitter, and there's a lot of picture services like TwitPic that you can then, when you go to TwitPic to upload a photo, or you have your phone connect to TwitPic to upload a photo and then show it on your Twitter account, it says, hey, I can tweet this for you, but I need Twitter to say it's okay. So sign on to Twitter and tell Twitter that it's okay that I post on your behalf. That is OAuth. OAuth is like giving your son a gift card. Whereas OpenID is like giving your son a MasterCard. All right? Okay. They're getting closer, people. I read speaking of Twitter, I read somebody made the comment, the air raids appear to have stopped, but now the machine gun fire is starting. Yeah, that's about right. So now we know why and who. Goodness gracious. Let's talk about how this is all implemented. And so far we focused on SAML and OpenID, so I'm going to continue in that realm for a little while. So ADFS and WIF is is excellent for passive clients and service-oriented applications. So we have Alice once again here, who's attempting to access an application in my domain, okay? So the application is the thing with default.aspx over here with a couple of pages inside of it. And it is encased within this pre-processing environment that's handled actually by IIS, largely, for those of you who are Microsoft people. When Alice tries to go to the application and say, hey, let me in, she stopped at the pre-processing layer, and it says, hey, give me your claims. Give me your identity. I don't know who you are. Normally, my app would have to have a login screen, right? You write a login screen, you accept the username and password, maybe you go check it with a service or something like that, and you come back. She's not even at the app yet, okay? IIS is stopping her. and saying, you don't have any claims, and she says, oh, I'm really sorry. Let me go get my claims from the secure token server. Okay? So she's getting an HTTP redirect not from our app, from IIS, to the secure token server to get her claims. Either it will pick it up from her Windows identity, if she's logged into a Windows machine, or it will prompt her with a login page where she will put in her credentials, use biometrics, use Radius, use her certificates, put in her smart card, whatever needs to be done. All that is handled within the STS, which is the public-facing interface to this whole big identity provider that we already have in place, usually Active Directory. Right? There's all these pieces that are already inside there, and instead of remaking them into each application, we're just going to use that. So she gets her claim, she goes back to the application that says, knock, knock, here I am. I'm sorry, she goes back to the application hosting environment, says, knock, knock, here I am. And they say, oh, you are Alice, and you're a doctor, so here is your page. Because I can use the claims that came with her in her SAML packet to make decisions about authorization, too, as well as trusting that she's been authenticated. The service environment looks very much the same, as you can tell by the fact that the picture practically changed not at all. Most of you probably didn't even realize the slide had changed, and I make that mistake a lot. But there's a key difference. In a service environment, we are already presented with the policy via the WSDL. So we know, as a service consumer, that the user will need certain things before we ever start. So the service consumer knows what they're going to need. They go to the STS, they do the same thing. They get their credentials, or the user's credentials, come into the application and are once again directed to the proper service. So that's a real high-level look at how ADFS will provide some stuff for you. And now I'm going to make everybody's eyes bleed. How many people in here would actually consider yourself a coder? Oh, awesome, okay. This is extremely tiny, and I'm very sorry. I would like to find a way to make it bigger and make it still have everything in there. But effectively, that top line there, where I go get an iClaims identity, that is the authorization step for this entire application, because the user is already authorized. I did not write a login page. I did not go check their identity, because I don't need to. Either their claim list is in that object or it is not. And if it is, they are allowed in. And if they are not, then they aren't allowed in, and that is the end of the story. What's more, my little check legal thing here will go and use their birth date, which happens to be in their claims list. Now, their claims list, remember, was given to, or the required list of claims was given to them at policy time. If this is a service, it would have been in the WSDL at design time. If this is a web application, then it would have been at request time. I gave the policy to them saying, hey, your birth date must be in your list of claims. When they go to the STS, they say, hand me my birth date. The STS says, yes, I'm allowed to give you that because I've been pre-configured to do so. Remember, this is Microsoft. And you get it in your list of claims. We can then check it, add 21 to it, make sure that it's less than today, and let them in or pass, you're legal if you are, and you're out of here if you're not. So that is how you do WIF. Let's talk about OpenID real fast. How am I doing on time? Oh, awesome, good. Okay, oops. So OpenID is much simpler, much simpler than WIF is. There's very little infrastructure up front except for the fact that the user has gotten a persona ID. You see our persona ID server up at the top there, and it's communicated it to some identity provider. So the user says, hey, I want to use your website, and the website says, nope, I got to redirect you to your identity provider, which I know because you have given me a piece of information, your URL, right? Your custom URL, like semf.myopenid.com or whatever like that. The identity provider says, hey, here's a login screen. You've got to give me your password, biometric token, whatever, in order to be authenticated. The user says, hey, no problem, here it is. And the identity provider sends a packet back to the website, the relying party, saying, okay, this person is legit. Here's the information I have about them. And the website then returns the page that the user initially asked for. Much more straightforward than much less configuration, but it's also much weaker. As you can see in some code here, really all you ever get back is failure, success, setup needed, which means, yeah, this user might have a URL with us, but they've never given us any information about them, so we've never heard of them, or cancel, which means that something happened along the wire somewhere. You don't really get very much back from the OpenID provider. Now, whereas ADFS has with as its API to say, for instance, OpenID has a whole range of IDs. It's simple enough. People are just building them. This is using one called Ruby_OpenID. It's on GitHub. And there's bunches of them out there. But basically, all of them deal with exactly the same thing. There's not much coming back from OpenID except for the fact that the user is authenticated. But what didn't we have to do in any of these cases? We didn't have to decrypt the packets. We didn't have to decrypt the URI. We didn't have to go through all this rigmarole. We didn't have to parse the SAML code. We didn't have to do anything fancy to get the collection of claims because it's been handled for us. Since it's a standard, we can have a common API that all our applications can use, no matter which platform you're using. And it takes so much weight out of the application developer's hands and the system administrator's hands to not have to deal with that anymore. So, let's talk about what ifs for a few minutes. There's obviously a lot of pluses, right? To distributed identity management. The apps don't have to handle their own login. The user doesn't have to, the systems don't have to maintain a user repository any longer. The user owns their own identity effectively. Trusted parties own the authentication of the user, and everything is encrypted, right? But there are still things that can go wrong, and everyone here is very familiar with risk assessment. Well, this is the other side of the coin. Anything encrypted is subject to a timing attack. And there hasn't been much in the way of timing attacks being used over the internet because the internet is too untrustworthy as far as the speed is concerned. But this year at DEF CON, and probably at Black Hat too, a couple of guys whose names I still didn't put in my speaker notes, I'm sorry, I need to do that and give them credit, have proved that you can find surprisingly small timing differences visible from the internet or remote stations in general. Sub 40 nanosecond numbers via the internet and 40 nanosecond numbers via the LAN and 25 microsecond numbers via the internet. So the old encryption attack where you take a SAML token and throw it at a server and then change the first character and throw it again and change the first character and throw it again and try to discern when the server takes a little bit slower to respond. They're a little bit slower because they decrypted the first character and they tried to work on the second character, more or less. That's an oversimplification, but more or less that's good enough for the purpose of this talk. Because so many applications are written in scripting languages these days, the applications are a little bit slower to respond in general, and we can get much greater responses back. So the encryption itself is a little bit more untrustworthy than it used to be. And that is a risk, potentially, especially if you're trusting via ADFS, trusting partners that maybe you wouldn't really trust that much, if you know what I mean. Realm misinterpretation is a big problem for OpenID, especially because what realm misinterpretation is the old phishing attack where instead of cgi.ebay.com, it's cgi.ebay.someevildomaininrussia.com, and the user goes, oh, it's from eBay, this should be fine, click. The same thing can be true of OpenID. The relying party can the identity provider can fool the user into logging in with their credentials by having their, okay, let me back that up just a second, sorry about that. The identifying server can be intercepted, man-in-the-middle attack, can be intercepted, and the user can be fooled into logging in to a site that isn't their actual identity provider. And just like fake Facebook pages or anything else, where they're collecting usernames and passwords. Anything OpenID related is susceptible to that attack because users just don't look at the URLs. They just don't. They don't look very carefully. So that's very much a risk as well. And finally, identity providers can just fail. They can fail to service the request. If you're internal on a domain, your STS can go down. If your STS goes down, every application stops working. Every one, because they're all dependent on the STS to distribute the claims, right? If your internet application requires Twitter and Twitter gets busy, you get a whole lot of fail whale, right? Identity providers can fail to protect the identities. You can choose to trust an identity provider that gets hacked and gets their database downloaded and somebody rainbow tables their users and gets up with a bunch of identities. And that can still happen. Now, presumably because the identity providers we're choosing, especially in the OpenID space, are big, they're big enough to be very visible and they won't make those mistakes. But we all know that that's not really how it works in the real world, that whole too big to fail concept. And also, identity providers can fail to keep the doors open. They can just go away. For that matter, Microsoft can just decide that ADFS isn't worth the risk and get rid of it. And when that happens, you have a whole lot of rework to do. Whereas if you're maintaining all of your own identities, you wouldn't. So there's 3 risks to take into consideration, and I'm sure you all can come up with more that we can do in the hallway track later on. So what do? Well, generally speaking, my take is this when I'm advising clients. You need to do a risk assessment. If you're in an extremely high security environment on the internet, you don't want to be accepting Gmail as authentication. You just don't. You want to maintain control over the identities. The Pharmacy Compounding Board requires users to have a user certificate and they manage it internally, and that's that. And for them, that's a good idea because you don't want anybody to be able to go in and find out how to mix certain drugs. That's a bad thing. If you're building something especially social, look at OpenID. It's very powerful. And people who use OpenID, for instance, just on their blogs, see a much greater conversation, much more rich conversation in their comments because users can just log in with their Twitter or Gmail or Facebook accounts instead of having to create an account with you and authenticate that way and then another password to remember. Internally to a enterprise space, Federation is a really, really strong contender if you have a distributed identification system anyway. If you are, my classic example is always the Department of Health, the state of Ohio, where I've done a lot of work, and all of their people, the many, many organizations that they do business with, all of those people have identities in each of the apps that the Department of Health provides, and it's a real problem. Because honestly, some of those apps are 15 years old and are subject to SQL injection and other attacks, cross-site scripting attacks and such as that, especially the early JavaScript ones. If you remove the login pages from all of those applications, that's one less thing you have to worry about and one less identity that all those users has to manage. So while Federation is not a panacea, it really does have a place in a lot of applications. You have to trust somebody else. And the whole chain is only as strong as its weakest link. But and you're taking the identities potentially out of your own control, which some of you may not like. But the benefits it brings from the user's perspective and from the management perspective are very, very strong. So here's some of the references. I ran a little short. I'm sorry, but that's okay. We'll have more time to drink coffee, right? Here's the references that I largely used. If you are interested in further learning about ADFS and WIF, especially for the Microsofties among you, Programming Windows Identity Foundation is an awesome, awesome book. It has a whole range of background information, and much of the philosophical parts of this talk were kind of gleaned from Vittorio's wisdom, and I recommend you read it, at least the first half. There's also a really great white paper out there that Keith and Sesha did called Microsoft Identity Foundation White Paper for Developers. OpenID.org has a very rich documentation section. If you're a public internet guy, just go surf their site for a while. It's eye-opening. And Wikipedia, surprisingly, has a really, really rich and extremely accurate identity management section in general that covers a whole range of topics. If it's something that you end up finding yourself faced with that maybe you haven't faced with before, you can actually get an education from Wikipedia, which is not something I normally say. But in this case, it really, I verified a tremendous amount of stuff, and it's really very rich.
We'll fix that by tonight.
Yeah, awesome. So, questions. I have 2 questions. Who the heck am I? There's my vital statistics, if anybody's interested to poke fun at me on Twitter or anything like that. And if, in case anybody slept through the entire thing, we were talking about identity management. And we were talking about using distributed identity management over discretionary. And that is, so those are my 2 questions, and I got some answers. So if any of you have questions, you can ask them for the group, or you can grab me afterwards. I'll be hanging around for a while. I'll be here through lunch and like that. But that's the beginning and the end of it. Thank you very much for allowing me to
Any
come
questions
in
for Bill?
and do this thing.
All right. Go see him in the hallway track.
Indeed.
Thanks a lot, Bill.
Thank you very much, gentlemen, ladies.